Hello everyone and welcome back to another Python's fundamentals video. Today we're going to be talking about classes. Classes are a very important, I would call it a container type, or a better word of an encapsulation of data types that's commonly used throughout all programming. It's a way to keep your variables and functions that actually work together within some encapsulated domain to be together. So you don't have to worry about trying to keep up with, when you want to utilize those sets of functions and variables. You have an object that represents the entire group. And that object is kind of called, we call it a class. And that's what we're going to talk about today. So let's go ahead and get started. And let's get to learning, get the programming. So again, let's do a little bit of background. So a class, and I got this written in the thing, so you should be able to read it as well. It's an object constructor, and it's a blueprint. Like I said before, it's used to be able to encapsulate a set of variables and functions into like one single entry, like in one single hub. That's kind of how I see it in my head. The objects get their variables from the class. And then another big thing is that a lot of time we put what we call doc strings within the class. So that's the triple quotes that we talked about in the Python basics. We have triple quotes, and you write up something about what the class is. It's called a doc string, and what it's used is to let people know what your class does, what are the data that it returns. Sometimes every function will have a doc string, so you write up exactly what the inputs are, what the parameters are, and stuff like that. In this video, we're not going to really get deep into that, but I probably will show like how to do just a general doc string for your class. The only other thing, another key thing with classes, you have this self parameter, and this self parameter is a reference to itself, like the class. So when you pass in objects into a class, you can use the self parameter to be able to store local copies of like what's being passed into the class within itself. So wherever this class is used, those self variables or self functions will be able to be utilized to solve the problem within the class. And then you have a super function, which allows you to get access to the self functions of the parent class. So again, you can have classes. You can have classes that derive from classes, which means that like they inherit, if they had a derived class, like an animal. I guess we'll do that example. Like if you have a dog, the derived class would be animal because animals are dogs. I mean, dogs are animals, but if you had cats, cats are animals, so they're both animals. To get access to what's in the animals self group, you have to use the super keyword. So the super gives you access to variables that are located within its derived class. Again, I know this is a lot of information up front, but you almost need to talk about it because if you've never seen classes before, this might be a little odd to you. I will also say make sure you're very comfortable with functions. Everything that I've discussed above this video, make sure you're very comfortable with because a class is really just a way of ordering all the things I've talked about in the previous videos, like how to add functions, how to add variables, how to put docs. Now you're having a system in which all of that stuff is going to have a folder that it follows within, and then you're going to have to learn how to access those elements throughout that folder structure, which we call a class. All right, again, I know that was a long intro, but let's get it now and get started. All right, so let's start by just creating an empty class so you can kind of see what it looks like. Go down here, I'm gonna say create empty class. Oops, spell this morning. And all you do, there is a keyword. We're gonna create an empty class that let's print out the hello world is my favorite intro thing. So we're gonna say class. We got a class. We're gonna call it hello world. Hello world. And then at the end of a class, you gotta have the parentheses, and then you do the dot. So if you want just an empty class with nothing in, there's a keyword called pass, and pass will allow you to create a class without having to have anything in the inside. For instance, let me show you what I'm talking about. If I try to run this line of code now and do shift enter, it's gonna say expected indentation block, but I didn't have an indentation block because I didn't put anything in it. So to put something, I would just use the keyword pass, and now if I run both these two lines of code, it will actually create the class. So the class is definitely there. I can show it to you. You know how like when we type and we get that IntelliSense to tell you stuff. If I type in HELL, you see right here, it says hello world, and it's a type class. You don't see anything because the class is just like I said, it's just another container type stored in memory that has the ability to have everything else in it. So if I were to call this class now, I say hello, like we do all the time, HELL, and then hit tab and then do shift enter. You see it gives you out. It has a main, it's a class, and it's located at this memory location. Now, so we definitely know how to create a class, but right now the class doesn't do anything. So say for this class, all we wanted to do is create a variable that has a statement that says like welcome to your first class, you know, like your first class. I know I'm being a little corny. And when you call this function, that prints out onto the screen. So let's do that. So let's create a variable within our class. Let's go down here. I'm gonna call it add a statement in the class. Alright, so now what I'm doing, I'm just gonna rewrite it each time. I'm gonna copy it here and copy it down here and then update it, so you can kind of see by the time we're done you'll have like a functioning class. So add this, and I want to remove this part. And so what I want to do is have a variable, let's call it statement is equal to, and in the statement I wanted to say welcome to your first class. Yeah, all right, first class. And then all I gotta do is run this now, shift enter. All right, so now we have this new class, and now to actually use the class we actually have to set a variable to the class. So when you run it up here, I didn't make that clear earlier when I did this. When I ran hello world the class, it gave me information about the class, specifically that it's a class because it has this main. It knows it has a main function that's built in that you don't see, and it gives me a memory location. But when you want to use a class, it's like any other variable. You have to set a variable to the class before you can actually use it. So in this case, we wanted to print it out a hello world. We have to create a variable. We'll call it my class. So this is my class is what I'm locally creating, and the class name is hello world. If I do this and do shift enter, now you see hello world is now showing up in the editor with my class. That's the type hello world. We know it's a class. It tells you it's a value here. If you double click on my class, this is specific to Spider. You see that it'll tell you kind of what's in your class. So right now we have my class is hello world. Inside of it there's a variable statement that's a string, and it's size 36 with this. So I like this. This is one thing I really do like about Spider. I'm sure Jupyter can do it as well, but Spider has a really good way of like looking and seeing what's in the class once you substantiate it and put it into your variable set. So we'll keep looking back and forth at this as we keep creating classes as well. So since that's the only variable and it's not really callable, right? It just, when this class is called, it just runs everything that's inside of it. In this case, because there is no specific functions to call. So if I go down here again and just run my class and then hit shift enter. My bad. Hold on. My bad. I'm wrong. You got to say my class dot statement because this is a variable inside of it. My class dot statement. See that statement is a variable in the class, and then do shift enter. You get back out. Welcome to your first class. Yeah, because and this is the only variable, right? When I did my class, that I set this class object as a variable to my class variable. Now my class has attributes now. So an attribute is like a string is an attribute. It's something. It's not a function. So it's pretty much classes have two types. You have attributes or you have functions. I mean, different books call them different things, but pretty much that's what you have at the base level. So something that describes something is an attribute. So if I had the statement is just a string. If I had a variable for eye color, that would be an attribute because it describes something. Functions are things that do stuff. So in this case, we don't have any functions. We have an attribute we can access, and that's what the dot command is for. So any attributes in here, or even any functions we want to access, we have to use the dot command to access those functions. So now, so we've done that part. We got a statement. Now, a lot of times, in this case, we just printed a statement, but this statement is just a variable within within the class. But if you really want to make sure that this variable is always there and is actually part of the class, this is where you first have to be introduced to the self command. So anytime when you normally create a class, you always add the self command, because the self attribute is what reference that allows you to create variables that are always going to be created and stay with that class throughout the life of the class in your program. So normally, I'm gonna rewrite this a little bit. Normally, this would be rewritten as self. Just gonna add this in. It's not gonna change anything. Self, the keyword self, and then this would have been self dot statement, which is the reference to this self. Self dot statement. Oh, it's complaining. Why is it complaining? Undefined self. Oh, my bad. Not that. I'm wrong. I'm thinking I'm still doing functions, man. So to do this the right way, I'm just laughing at myself. I'm still thinking about the last video I created. You actually have to have a constructor. I will do it as another line. So here we just created a variable within the class that that we can access it. But this ain't the way you normally write it in class form. I'm just still laughing. You would pass in the self variable from a init function. An init function is like what we call a constructor in like older language. So when the creation of the class is being built, anything in the init is assigned in creation of the class. I know it's a lot of information. If there's things that you want to happen or be assigned to things in that class during creation, you have to do it with a init or a constructor. So for instance, to do what I just said here, I'm just going to copy, this down here just to keep it from where it looks confused. Put this line here. I don't want to be confusing people. All right, so down here, we're going to add a constructor. So this statement can actually be part of the class instead of just a variable in the class. Okay, so if we go here, I'm gonna put it's def. It's a function. So there's a special function. You have the def underscore underscore init underscore underscore. This is a special function, and if you hit tab, it expects you to have the self function in it. So the self function would be the first argument or the first parameter to all your functions within a class. That's standard practice. So if there is anything that needs to be stored in the class, you always will have self accessible to everything inside your class. All right, so we put the self function in, and then once we have the self function, I think I just put that there, and then I would say tab to get it over, and then self dot statement, and that's the only change. So now this setup with the constructor, I'll say added constructor, We added a constructor here, and now we have an ability for it to have access out, right? So when we run this line of code, that'll update our class code. Then we'll rerun this line to, we're just rewriting over our original class. So we do shift enter on this line. And let's go look at it. Let me see something. Oh yeah, because that statement isn't there like that anymore. So we go look now. It looks the same, right? You don't see any difference. Yeah, don't worry about opening that. That's more information that you want to know about. But from this perspective, everything looks the same. Try to figure out. Oh yeah, but the only difference is that. Give me 1 second. I don't think this is the issue. Oh yeah, there we go. I don't know why this thing is I don't know why it's giving a syntax. Oh, because I have this line. My bad. I was wondering like what's wrong. All right, so again, everything is the same. If you click up here, everything looks the same. And then here, when you run this statement, it's the same. So up here, I set up the class again, and then when you do the statement, it'll print out the same thing. And this you'll understand why this setup is more important than this setup once we start looking at a more complex example. All right, so now we know how to set up what we call a base class, where we got the hello world class. We gave it one variable that the class owns, which is the statement variable. And that's that. I mean, I want to show you before we move on, because I don't want to go too fast on class. I want to kind of show you why this is important. Say if we had added another argument here called new statement. New state. I'm sorry, I was thinking about how I wanted to write it. So we had a new one called new statement, right? So and I'm gonna say, yeah, new statement is equal to 0. That means that it has a value for it when it creates it. So, and in here, because you remember I told you last time that we talked about function, this part is a function. This part of the class is a function. So you can do anything in here is ran when the class is created. So I could have a variable here where if I said if new statement, remember new statement it knows it's coming in. If it's not equal to 0, I want self.statement to equal new statement. So just make sure you understand what I'm trying to do. So when somebody create a class and they don't put anything in the arguments, so in a class you put your arguments at this part here. If somebody doesn't put anything in the argument, when the class is created, a new statement will be equal to 0. So when it's created, self statement will be assigned this, okay, and this will be checked, but it's equal to 0, so nothing will happen. But if they create the class and actually put a string in here, this will be overwritten, and statement now would be whatever was written into that slot. So I just wanted to show you this example. So right here, when I run this line of code again, shift enter, I don't think anything even looks different over here, because this is only going to show you the variables and all the methods within a variable. So you don't see that. But now when we go over here and run this line of code again, okay, and then this line of code again, as you see, it says welcome to your first class. Nothing changed, right? But if I go here again and recreate this class, my class is equal to hello world, but actually put in the constructor part, I have changed your mind. Okay, and then when I create the class with this, shift enter, and then I go up here again here and just run my statement. Shift enter. I have changed your mind is populated now, not welcome to your first class. Because what happens is this now is passed into this is passed into the class when it's created. Remember, here it's not passed in, so nothing was passed into the class. Once this was passed into the class, when this got called, it ran this function, which is the init function, the very first function that's ran. If this function exists in a class, it's going to be the very first function that's ran in your program when the class is actually built. And in that, constructor or very first function run, it does this in here, creates that, set it to that, makes this check, and then that's in this one the check failed because this is not equal to 0. This is equal to this statement I passed through, so therefore it changes itself statement, the variable it owns, so I can print out the same statement both times, and now the statement has different values for it. Okay, so again, that is, this is the heart of what we're talking about. Really is the heart of function. The heart of classes, of basic classes. So it's worth spending a lot of time making sure you understand the base principle. Another thing, so you can add, you can conduct like print statements, you can conduct all kinds of things, or you can take in other variables and actually use those variables within your class that's being passed through. So for instance, say for the Hello World class, I want to copy it down here. Let me this. For the Hello World class, let's copy it again and just keep adding to it. I wanted to say my first name first, or whoever's names that gets passed into it. In a second, copy. Oh, here we go. All right. So for instance, instead of it says welcome to your first class, I wanted to say Michael, welcome to your first class. Okay. So what I need to do, I want to pass in my name, and then what I'm gonna do with the statements, I'm just gonna add a print statement in my class that takes in my name and add it to the other. So what I'm gonna do, I'm gonna take in another string, and I'm gonna call it name. So now that's going to be another argument that's needs to be used to be able to create this class. My bad, I didn't mean put the J, just name. And then inside here, when it prints out statement, instead of printing out statement, we're going to create a function that prints out statement, or prints out what's the word? No, I'm not. I'm going to use the print function instead of when I call the statement function, I'm going to use the print function to be able to do it. So let me see how I want to set that up right quick. I'm going to create another self argument, and I'm going to call it name. So self, it has a name, and I tend to use the same name convention. So when I say self.name, I'm creating a variable called name, and then equal name is the name that's actually the argument that's actually being passed into the class. So creating a variable name that's within the class, but that name variable is being assigned from the name variable that's actually being that's coming from the outside of the class, that's being passed into it. So it gets the statement, if there is anything. This gets the name, and then when it gets done, I want to print, and then I want to print name, and then I want to print self name. I think I need to say, do I need to say self name? No, I think I just need to say name and statement. I might be wrong on this, but I'm not 100% sure, but we'll check it out. I know I need name and statement there. And I need name and statement in the if statement in case this is called. Oh, I got it. So this is being called because you can't have a default. What I did the default earlier, you can't have this here when you have a variable that comes after it. So if I want to use this same default, I will have to switch these two positions, because the one that has a default, which is the default in this one, is 0. That variable has to come out. It has to be the last variable. All your defaults have to be the last variables. So all I'm going to do is take the name variable and move it in front of the new statement variable. Oh, I got an extra comma. Okay, so this is, oh, so now I see the issue. So it is, I definitely need to put self.name. I wasn't sure. It's been a while since I created a class from scratch. I was wondering, was it self.name or not? Right. Okay. So self.name and self.name. So you set up the variables here. When you access these variables, you have to have the self command, because these variables can be accessed outside of this function. So that's the reason why the self command is necessary. So you can say, I'm referencing myself and I want to use you somewhere down the line in your class. You'll have access to to those variables. So now when we run this class, make sure it runs first. Let's see if there's anything different over here. I don't think so. Nope. Okay, so now when we create the class, we'll say my class again, just like above, is equal to, now this time we have hello world. See, now it's telling us it's looking for, it gives us an arguments list because it knows it needs something. So I'm gonna type in Michael. Okay, so that's the, and then I'm gonna leave it like that, and then I create it again, and then I type in Michael and the other statement, and then we'll see what happens. So when I create the class this way, you see it says, now it prints out Michael, welcome to your first class. Yes, because it creates the class, this variable name, which is this variable here, the argument, this parameter name was assigned Michael, and then new statement was assigned its statement within the class. So it was assigned this statement. So when it got done and started to hit the print line, it print this name, and then it checked this and didn't do anything. So I already see I have an error, and I'm gonna let the error happen, and then I'll tell you why it happened. All right, so what we're gonna do again, we're gonna create another class here, and that's gonna do the exact same thing, except we're going to add the second statement. We have comma, and what did I say? Welcome. What was this? I've changed my mind. I have changed your mind. Okay, now when we call this class and it gets created, watch what it prints. Okay, it prints Michael, welcome to your first class, and Michael, I have changed my mind. Why did it do that? Because that's why I knew it was going to do it when I was writing it up here. Because this statement gets built, and I have this print statement here, but this print statement needs to be inside of a loop. So I got it here. I just should move this from this place and put it in an else loop down here, and that would solve it. So what's happening is when it's getting printed when it's being created, because remember I told you this function is called at the beginning of the class life. So when it's getting created, it prints the statement. So it shouldn't do this. It should do this. It should do a check first to make sure that it should print this statement based on is anything in this. So this print statement should be down here with the else statement. So I just need an else colon, enter, and then just move the print statement here. So it's just a mistake in my code structure. So I'm gonna copy all of this and I shift enter. So now when I create the Michael with my name again and hit shift enter, it says welcome to your first class. Yeah. When I create it again with this one, shift enter, now it says Mike, I have changed my mind. So like again, just making sure these are the type of things you're going to have to debug in your class too. So you got this function within your class that has these variables that are accessible throughout the class now. And then you have this control structure here in the middle that's determining what it prints out on the console screen each round. All right, so actually I think we're going to stop this video here. So this is going to be Python classes part 1. Let's do a recap. So today what we done, we talked about creating an empty class. We talked about how to add like a variable to a class. We talked about the self function. We talked about the constructor, Python's constructors, and then we talked about how to pass an argument, and also how to have a what did they call this earlier? A reserved value for the parameter in the class. We talked about that as well. Then we also I showed an example of using the self command, and then using the print command within a control structure to print out when a change to the argument has happened. So that was pretty much what we covered today. In the next video, we're going to talk about inheritance. Because I would say inheritance is probably the big other piece to this kind of class structure. It actually what makes classes so powerful, to build the ability to be able to use inheritance. And I want to separate it from this video, but first, before you even look at that video, make sure you're really comfortable with doing what's in this video, because it only builds, and if you don't understand how a class is built without it having any type of inheritance or any type of special variables and stuff, it's not going to make as much sense. So I wouldn't go to the next video until you understand that you're actually comfortable with classes and everything that's been taught above this video. But if you are comfortable, definitely watch the second one. All right, thank you for watching. I hope this was helpful for you. And always, again, happy programming.